The purpose of this video is to understand how to program your Arduino to make it work in a closed loop system by sensing the output voltage. The fundamental aim here is to sense the output voltage and give that output voltage value further to your lines of code which is present inside of the void loop, which will perform the digital controlling action. So as a first step, you need to compute the error, and for computing the error you need a reference voltage and the output voltage. So the process of sensing the output voltage is the focus of this video. So there are two methods or two approaches in which I have framed this particular video. First, we will understand how a voltage is converted into a mere number in Arduino. Then we will go in the programming approach, where we will know the number which is available to us, from which we have to predict what is the voltage which is at the sensing side. This is just as an overview. So as a first part, I would like to go to our basic circuit here, which contains the converter, as well, and the area or focus of this video is in this window. It is, we are going to use a voltage sensor module, get that output voltage and convert it into a mere number, v underscore o for v out. Okay, so if 12 volt is present here, then I should get 12 volt here. So this is an analog world, so we have an ADC in between which will do the process. So this is the main aim of this video. So we have something called as a B25 voltage sensor module, which is used to measure voltages up to 25 volt. Here my converter is having a nominal voltage of 12 volt, so it's well below 25 volt. Therefore I will use this voltage sensor module. If your output voltage is far higher, like 200 volt or 250 volt or something like that, you may use Hall effect sensor as well. Now this R1, R2 is just better resistance potential divider. Why is it necessary? The maximum voltage that my analog pin in the Arduino can withstand is up to 5 volt only, maximum of 5 volt. However, I want to measure 12 volt. Can I feed this 12 volt directly to here? No, I cannot do it. So I have to step it down and then give it to this Arduino having a value lesser than 5 volt. So this is nothing but my voltage sensor module, simply just a resistance potential divider. You could see two surface mount resistors here. One is of 30 kilo ohm, the top one is of 30 kilo ohm, and the bottom one is of 7.5 kilo ohm. So when you look into the ratio R2 upon R1 plus R2, you will get 1 by 5. So whatever voltage is available here will be divided by 5 and it will be given to this particular two pins, A3 and G and T. You can give any analog pin. I am taking A3 for this entire example. So I will give my positive from here to this plus VCC, negative from here to this ground, and then I will take two outputs, one from the middle of the two resistors, which is S, and the other from the ground, which is minus. Here this plus terminal, the middle one, is not connected. So this is your plus terminal, this is your minus terminal. So this is how it is. Let us move on further. As I said earlier, let us first understand how the voltage conversion process is happening, how an analog voltage is converted into a mere number. As I said earlier, this is 30 kilo ohm on R1 and this is R2, 30k, and this is 7.5k. Assume that I am having some voltage called 15 volt. I'm taking 15 just for numerical easiness. It may be 12 or near 12 in your case under steady state. This is the output of my converter or V0. So this is my V0 now. So when I'm giving 15 volt across this terminal, what will be the voltage I will be getting here? It will be nothing but R2 upon R1 plus R2 into V0. So this will be the voltage which will be appearing across this two terminal. Let me call this as V sensor or VS. So this VS is nothing but 1/5 of your V0. 1/5 because of it is 7.5 upon 30 plus 1.5. So if I'm giving 15 volt here, what will be the voltage across these pins? It will be 3 volt. 15 upon 5, it will be 3 volt. So 3 volt is well below 5 volt. It is well within the specification of analog voltage that Arduino analog pin can withstand. So this is my A3 pin and this is my ground pin. I am having 3 volt here. Now this 3 volt is fed into a 10-bit ADC. A 10-bit ADC will convert this 3 volt analog into a 10-bit binary number. So when I say a 10-bit binary number, it's simply a 10-bit register, maybe a 10-bit 1001, something like that. So it converts this 3 volt into some zeros and ones combination. That's why it's called an analog to digital converter. And every ADC, should have a clock. So there will be a clock present here. We'll come to this clock part later. For now, let us not focus on this. So this 3 volt is converted into a number. The question is, what number is it converted to? For that, we need to first understand what is the maximum possible number which can show up in this. Since I told you that it is a 10-bit ADC, it can store a minimum value of 10 zeros and a maximum value of 10 ones. So this in binary will give you 0. Sorry, this binary in decimal will give you 0 and this binary in decimal will give you 1023, which is nothing but 2 power 10 minus 1. Here 10 because it's a 10-bit ADC. Now, when I'm having 0 volt across these pins, if I am having 0 volt across these two pins, then the output of my ADC will have all zeros. So this value 0 will correspond to 0 volt. On the other hand, if I am having 5 volt here, then all the bits will go up to 1 and this combination of all ones, that is decimal 1023, will correspond to 5 volt analog. Now I am not having 5 volt here. I am giving 15 volt here. It is getting converted to 3 volt. So what should be the number? It is very simple. We'll go by proportionality. So assume that my question is, for a voltage of 3 volt, what will be the number here? So by proportionality, I can go, if 5 volt corresponds to 1023, then 3 volt corresponds to what number? So that number is nothing but 3 by 5 of 1023. That is, you will get somewhere around 614. So this 614 is the value or the binary of the 614, which is a combination of zeros and ones up to 10 bits, something like this, will be stored in this register. So if you give 3 volt, the binary of 614 will be stored here. So Arduino will give you a provision to directly access that number. So how can you access that number? Is you need not do all these things. You simply just have to call a function called as analogRead. So the moment you call a function called as analogRead, assume that I want x equals analogRead of which pin? I'm connecting to pin A3, so I should say A3. The moment I write something like this in Arduino, my x value will be 614. Why? Because this 3 volt is present here. This 3 volt corresponding number is 614. So now x will have 614. This is how your voltage is converted into a mere number. Now the real problem, this scenario what I have told you is for understanding the concept. Now the real problem won't be like this. The real problem is I don't know what voltage is present here. This is the voltage at the output of my sensor I am willing to know. Now what you will have in your hand is, you will write a statement like x equals analog read of A3. You will write a statement like this. So when you write a statement like this, you will get a mere number. You will get a number called as 614 here. Now with this number, you will have to guess what voltage is available here. Since you already know 614 stands for 15 volt, to make things interesting, let us take some unknown number such as 300. So I am telling my Arduino, or I'm writing a line of code in my Arduino. It says x equals analog read of A3, and it's giving me a number called 300. Now I have to find out what is the voltage present here with this value. So this is a reverse process actually. This is the thing which will actually you need to do. So you will take this value 300, and first of all, now this 300 is here. Now you have to find out with this system, just focus on this black box. The output of this black box is 300. What will be the input of this black box? What will be the voltage at the pins of analog Arduino, at the analog pins of Arduino? What will be the voltage across this? You have to find out. If 300 is a number, then what is the voltage across this? It's the same principle. If 0 corresponds to 0 volt, if number 1023 corresponds to 5 volt, then what does number 300 correspond to? It's very simple. So you don't know what number this is, you don't know what voltage this is, right? So this voltage at the sensor output or at the analog pins, this is your A3, this is your GND, and this Vs is given by proportionality rule. You should do 300 upon 1023 into 5. So if you do this, you will get the value at the output of this particular analog pin. You will know the voltage value here. So let us compute this. This will give you a voltage of 1.467. So here I know that now my voltage is 1.467. I know this now. Since I know this, I can find out this. This is the reverse process. I know that Vs is equal to R2 upon R1 plus R2 into V0. I know this as a fact. Now I have Vs with me. I want to find out V0. So V0 is nothing but R1 plus R2 upon R2 into Vs. I am just rewriting this equation in the reverse format. So this is the V0 I am interested to find. So this is how I will find out my V0. So this is what is explained here. So what do we do? If I give a voltage here, it's going here, stepping down, then it's converted into a number. But what I'm having right now in my hand is this. If I'm having all zeros, it's 0. If I'm having all ones, it's 1023. I am having, say for example, for a number 204. This is the number that my Arduino is returning to me. So with this 204, I need to first multiply 5 by 1023, just like I did here. Multiply this number by 5 by 1023 first, and then I will arrive at the voltage value at these pins. Then I have to multiply this with this ratio to get the actual measured voltage. Now how can I write this? I will write my Arduino lines of code something like this. I will write x equals analog read of A3. Now this is my x, this 204 is my x. So what will I do? I will write V underscore S or V sensor, this particular voltage equals x multiplied by 5 by 1023. I will write this. Now I got Vs. Now my V out will be R1 plus R2 upon R2 multiplied by Vs. So if I do this, I'll get this particular thing. Now in a single equation, I can write it like this. I can write my V out as analog read of A3 multiplied by 5 by 1023. I'm just combining all these three equations together. Multiplied by R1 plus R2 upon R2. So this is a single line in which I can put this entire thing together. Now 5023 R1 R2, all these values are fixed. So this entire term here will give you a mere number, maybe something like 0.02 or 0.04, something like that. It will give you a mere number. So I can write V out equals analog read of A3 into this mere number. That's it. So now I got the output voltage. From next step, I will do my error equals Vref minus V out, and then I'll proceed. So to find out this V out, you need to undergo this process. So this is how voltage is measured. With this, the main concept gets over. As an additional information, I would like to tell you something. This ADC box inside an Arduino will have a clock, as I said earlier. This clock should be having a certain frequency that does not compromise either accuracy or time. So what does this mean? My system CPU is at 16 megahertz. So I can divide or prescale the 16 megahertz by these values and make my ADC clock operate in the prescaled value. Assume that my system CPU clock is at 16 megahertz, but I want the ADC clock to operate only at 1 megahertz. If this is happening, then I should make these bits in this combination. I will go to this ADC SRA register and make ADPS2, ADPS1, ADPS0 in this particular combination, so that I will get a division factor of 16 and I will get 1 megahertz of the output. Why is this necessary? First of all, this is necessary to tune your ADC according to your speed. If your ADC is having a very high clock frequency, it will be more accurate, but it will take more time to give you the output. On the other hand, if your clock pulse is of very low frequency, the ADC will be very fast, but it will be less accurate. So to balance between accuracy and time, we need to choose an optimum value. So I have chosen the optimum value is 16, and for attaining this, you need to configure these things. So now coming to the final part, your program will look something like this. All these were already discussed earlier. This is for timer configuration for producing the sawtooth waveform. This entire thing is for that purpose. What's new here? This is new. What am I doing here? This is the process I'm doing. I'm going to this register and making these bits in this combination so that my ADC functions in a faster way. And this will happen in the void setup, the void loop. I am writing this V out equals analog read of A3 into this number, and I will repeat once again. This number is nothing but 5 by 1023 multiplied by R1 plus R2 upon R2. This number is got by simplifying this particular expression. When it comes to R1 and R2, though they claim R1 to be 30 kilo ohm and R2 to be 7.5 kilo ohm, always better to measure it by yourself. So you can use multimeter and measure the resistances of these surface mount resistors. Keep the multimeter across this terminal and this terminal at once. Measure the value. It may not be exactly 30 kilo ohm. It may be 29.7, 30.2, something like that. Take that exact value. Similarly, keep it for this. Take that exact value. And when you are initializing the variable for R1 or R2, use that practical value.